Hello, guys. Welcome to NT Podcast, Science and Theology. I'm your host, Nemanja Jurišić, and today we will discuss about fine-tuning argument for existence of God with Dr. Luke Barnes. Dr. Barnes, welcome. How is it going?
I'm doing very well. Thanks for having me.
Let me just quickly introduce you to my audience. Luke Barnes is a theoretical astrophysicist, cosmologist, and postdoctoral researcher at Western Sydney University. He received his PhD in astronomy from the University of Cambridge in 2009. So, Dr. Barnes, can you share with us how our fine-tuned universe points to God? And after lecture, I prepared some tough questions for you. So, floor is yours.
Good. Let me share screen and jump straight into it. Share and that should be it. So the finding of the universe. So there's two parts to this talk. Roughly, there's the bit that's scientific, and there's the bit that tries to use that science, tries to think about that science to understand some deeper questions about God and such. So yeah, let's jump straight in. I'm an astrophysicist and a cosmologist, which means I look at things like this. This is a picture with the the Webb, the James Webb Space Telescope. It's the central parts of a galaxy. These are swirling dust clouds, or gas clouds. Um, my job is to try to understand how the universe works. And one of the reasons why it's such a great job to have and why a lot of people go into science in the first place is that the universe, as you can see, is a remarkably beautiful and intricate place, not just in astrophysics, in the universe as a whole, but also in the small details of flowers, in the way fluids flow around the ocean. They could just slosh around in any old way, and yet we get these beautiful waves on the beach, even the sort of size and grandeur of things in the universe. There's a first impression of nature that, and I hope this video comes on the recording, but there's a first impression of nature when we go and look at the world around us that it looks well put together, in a sense. It looks like the sort of thing that would need a lot of thought and a lot of skill, a lot of ingenuity, a lot of design. That's the first impression we get about the world around us. If there isn't a God, how is the stuff of nature such, astoundingly well put together, interconnected, organized stuff? So I call this the design intuition. So before we think about arguments, before we think about evidence, before we do any of that, our first impression of nature is that it looks well put together. Now, I'm not the only one who thinks this. I think this is actually one of the main reasons why most people, most places in the world, for most of human history, have believed in God. If there's no God, then why is the stuff around us such amazing stuff? But it's interesting to see even someone like Richard Dawkins say something like biology is the study of complicated things that give the appearance of having been designed for a purpose. Physics is the study of simple things that do not tempt us to invoke design. So, what Dawkins is saying there is that when he looks at biology, at living things, at the hummingbird, at the um, elephant, at the rose, at in one of his books, the book that this is from is The Blind Watchmaker. There's a long section about bats. He's quite clear. They give the appearance is the important word here, appearance of having been designed for a purpose. But the reason why he is an atheist and why he doesn't believe there is actually a purpose, actually designed things in the universe, is that he thinks that physics is the study of simple things that do not tempt us to invoke design. Now, there's an in-between step there. You've got to then show that biology, the stuff of life, the stuff of living things, living organisms, connects to physics. And his book is about Darwinian evolution, which is about exactly that connection. How is it that physical processes could have produced life as we see it? Now, this is not a talk about evolution at all. What I'm really going to focus on is this second claim. Physics is the study of simple things that do not tempt us to invoke design. In other words, what he's hoping is, because he's not a physicist, but when people look at physical things, basic physical things, electrons and space-time and all that sort of stuff, that they will not be tempted to invoke design. They will not look like the hummingbird or anything like that. In other words, what Dawkins wants is what I've called the rematch. Biology looks designed, and if biology was all we had, then there would be the appearance of design. But we've got physics, and he thinks he can ground biology in physics. And then he thinks when we look at physics, we won't be tempted to invoke design. So this hope is that when we go down to we can ask the following question, right, to put it another way. Are the fundamental physical processes that shaped our world boring and unexceptional and unremarkable and typical? Are they not like the hummingbird, not like the rose? Are they just boring stuff down at the bottom of the universe? That's his hope. Because then, if all there is just physics and biology comes out of that, and physics is boring, then we can say, oh, fundamentally, there's no design. It's just the appearance of design. So, what's interesting also about Dawkins is he gives us a method for this. It's in the same book, in the same chapter 1 of The Blind Watchmaker. He says the following. There's a long quote on the next slide, but I'll read the whole thing. It is true that there are quite a number of ways of making a living, flying, swimming, swinging through the trees, and so on. But however many ways there are of being alive, it is certain that there are vastly more ways of being dead, or rather not alive. You may throw cells together at random over and over again for 1 billion years, and not once will you get a conglomeration that flies or swims or burrows or runs or does anything, even badly, that could remotely be construed as working to keep itself alive. In other words, even if I gave you all the cells of a hummingbird, the trillions, I think, not sure exactly what the number is, even if I gave you all those cells, and cells are remarkably complex to begin with, but even if I gave you those pre-packaged and you were allowed to sort of throw them together at random, right, put them all in a great big box and then just shake the box for a while, Dawkins says here, you can throw cells together at random over and over again for 1 billion years, and at no point will you open the box of randomly arranged cells and something will fly out of it with overwhelming certainty. I mean, it's possible, but it's ridiculously unlikely. So when Dawkins says the appearance of design consists in this sort of thing, that I see something about the world that doesn't look randomly arranged, that if I compare the way the world is to the way a thrown together at random world would be, I find that there's a massive difference. So there's a method here. How do we detect design? Well, in biology, Dawkins asks the question, what happens if you throw cells together at random? So if we're applying the same method to the same question that Dawkins asked, we would ask in physics, what happens if you throw a universe together at random? Now, how are we going to do this? Because we're not going to do it literally. Well, we can do it using physics. We can at least know what would happen if a universe had different laws to ours, because we can do theoretical physics. We can write down equations and solve them and predict what would happen if a universe were governed by a certain set of equations. How are we going to do this? Well, here's a proposal. When we look inside the fundamental equations of physics, we find something that represents the stuff of nature. So you look at these equations, there's something that says mathematically encapsulates, like, here are where the electrons are, or here's where the light is, or whatever. And then there's something that encapsulates the sort of the shape of the law. So there's something about the form of the equation that tells you how those things change. How do the electrons move? How do they interact with the light? How does the light move? On top of that, there's something else that goes into the equations, which is called the constants of nature. There's something that represents the stuff of the universe, something that tells you how it changes, and then just some numbers that go in as well. Things like how heavy is an electron, and things about the way the universe expands as well, and if we're putting sort of initial conditions into the same basket. Yeah. So the proposal is we want to throw a universe together at random. It's quite difficult technically to think how we would do that with the stuff and the laws. We could just try a few things, but it wouldn't be systematic. So the proposal is let's throw together at random these numbers, these constants, and see what comes out. Now, it could have turned out that you throw a universe together at random by changing these numbers and just a different universe comes out. You know, it has slightly heavier atoms and slightly stronger chemical bonds or something like that. It turns out that even extremely small changes to some of these numbers make an enormous difference to the way the universe would have turned out. The reason for that is these numbers are right back at the bottom of the universe. So if we broke the stuff of your body down to the basic stuff, up quarks, down quarks, and electrons. Just think of like three different types of Lego brick or whatever. Um, Out of those, you can make protons, neutrons, and electrons. Out of those, you can make atoms. And there's more than one type of atom. There's all the periodic table worth of types of atoms, the elements. And we can put atoms close to each other, and the electrons will go around the whole thing, and you make a water molecule. That's a chemical bond. And if you put enough of those in just the right order, you can see the structure here of DNA, where you can write the instructions for, a person. And specifically, those instructions, when sort of implemented, will create the basic building blocks of cells, and cells make people, and we're off into the world of biology. But it all, working our way backward, it's all built out of these fundamental things. So what if I change their properties? Let's think about one of their fundamental properties, which is just mass. How heavy is something? Get a set of scales, put one electron on there. Well, it'll have to be a really good set of scales, but we know how much it weighs. It's a very, very small number, of course, in any sort of reasonable size unit, but we know that number. And if we start changing these numbers, the mass is the up quark, the down quark, and the electron, the universe doesn't just get heavier because mass is a form of energy. The one equation in this talk, E equals mc squared. Einstein taught us that. So actually, these masses go into the budget of the universe. If you want some process to happen, you've got to make sure there's enough energy there. And if you want some process not to happen, like all your DNA falling apart, we want that not to happen, make sure there's not enough energy there. So if you start changing these numbers, you actually start determining what processes can and can't happen in the universe, which in turn influences what is and isn't stable, what can happen, what can't happen. So it turns out, for example, here's a very, very simple picture of an atom, proton and neutron stuck in the center, electron going around the outside. If you change the mass of these fundamental particles by a small amount, you'll suddenly hit these sort of thresholds where if you step over the line, suddenly things like this happen, right? The proton and the neutron don't stick to each other anymore. That's not a stable system anymore, and so you don't get any elements, you just get protons. Actually, there's a whole bunch of really sort of slightly entertaining ways of doing this. With another change to the way the masses of these particles, you can make the electron not go around the nucleus, but spiral into it and turn it into a neutron. So think about the case where a proton and a neutron won't stick to each other. Here's the periodic table. You're made out of these elements. Just for fun, this is the astronomer's periodic table, which is colored according to where that element is made in the universe. Actually, I'm just starting to notice now, I need to update this slide. It's a little bit out of date because there's some other things going on. But supernovae, for example, make all these sort of orangey ones. So if you've got gold anywhere on you, that was made in a supernova. However, the fact that our universe has all these different types of elements that life can make use of, all of that changes if protons don't stick to neutrons, because then here is the periodic table. You can't make anything. You can't stick anything together. You just have hydrogen. It's a one element periodic table. The number of chemicals you can make out of this, number of molecules to be specific, is one. You can make a hydrogen molecule, and that's basically it. That's the whole story of the universe. Like, that's all the chemistry there is. Our universe has, we have here on Earth databases of all the known chemical compounds. There are millions of them. But with a very small change of these fundamental numbers, we can go from millions of chemical compounds down to one molecule. And, obviously, that won't stick to anything else in any sort of systematic, rigid way. And that's basically it for all the structure of the universe. Just to make this point in a little bit more technical detail, if people are interested, we could actually map out these possibilities. If I want you to choose three numbers, right, the mass of the up quark, mass of the down quark, mass of the electron, well, I can represent that choice as a point in a three-dimensional space, like what you see here. So I'll point in a block, right? So this is a menu. If you choose a point over here, you get some electron mass, some up quark mass, some down quark mass. So you have a point over here, point over here. Pick somewhere and I'll make you a universe and we'll see if it's interesting at all. So we're in the middle here. The top is limited by the fact that we don't have a theory that can deal with very, very heavy particles because they would sort of become their own black hole, but they're a quantum mechanical thing and we don't have a theory of quantum gravity. For technical reasons, we actually don't know what would happen up here. And if you try to just make quarks lighter than a certain limit, that actually doesn't work either. Other mechanisms kick in to give them an effective mass. So there's some technical reasons why we've cut things off, but there's 60 orders of magnitude, 60 powers of 10 here available to you for your masses. So you're picking three numbers, and on some sort of units, they're between, 1 and a number with 61 digits afterwards. So there's plenty of space in there. What happens if you start choosing various bits of this block? Well, here's an example. Those sections I've cut off around the back, if you chose a point in there, you would have exactly the same problem that we saw before. The fundamental bits that you can make out of quarks, which in this case wouldn't actually be protons and neutrons, it'd be other particles, but never mind the details. You have quarks. Out of quarks, you can make composite particles like protons and neutrons, similar to those, but then you can't make anything else. So the universe is just unbelievably simple. It's the one element periodic table situation again. There's just no way to make structure out of the parts of the universe that you might have been able to. Beyond that, we can actually start cutting off other bits where similar sort of things befall the periodic table. If you want to make any sort of structure out of the fundamental stuff of the universe, where do you have to be? Turns out you have to be in this very thin slice. Otherwise, you have regions where electrons are captured by the nucleus, so all the electrons get eaten up, so chemical bonding is done, where hydrogen itself is unstable. And beyond that, if you want your elements to power stars, for example, to provide energy from fusion in a gravitationally bound thing called a star, you have to be in this little section. So this is a visual sort of picture here of the fine-tuning of the universe. All of these options here, every point in here is mathematically fine. There's nothing mathematically wrong with any of these. But when we look at what would have happened if you had a universe with, this up quark mass and that up quark mass and this electron mass, say down here, we just find that they are mathematically fine, but really boring. They just can't make any structure, and they can't make stars to sort of power anything made out of that structure. So this is a picture of the fine-tuning of the universe for life. It could have turned out, before we did these calculations, that how many elements in the periodic table are there in various bits of this space we're investigating. It could have been, there's 92 here, as in our universe, and maybe there's only 50 over here, and maybe there's 140 over there, and maybe there's 25 over here. And we'd be like, it'd be interesting, different universes. Who knows what we'd make out of them? It's not what we find. Here, 92. Everywhere else, 1 or none. And that's the way things go if you start throwing a universe together at random. They just don't fly. Now, we can ruin some universes in some other ways. Stars, as I just mentioned, are very important to life in our universe. They do an awful lot of interesting stuff. Any sort of conceivable life needs a power source, an energy source. And those heavier elements, heavier than just hydrogen, are very important for life, because hydrogen and helium are just too simple. Carbon is amazingly complicated. And the carbon in our universe is made in stars. So there's what our sun actually looks like if you don't stare at it with your eyes, but get I think it's a satellite to look at it very carefully. Stars rely on a balance between gravity's pulling in on everything and the force that's holding back gravity is heat. It's because the star is very hot that it's not collapsing on itself. That heat is ultimately sort of sourced from nuclear reactions. What would happen if we made gravity a bit stronger? Well, our stars in our universe have the ability to retain their stability, even if they undergo a bit of a perturbation, if they have a bit of an odd day. So if for some strange reason the center of the star gets a bit hotter one day, well, then there's more heat pushing out, and the star will expand a little bit. But because of that, it'll cool off, and then gravity will get a. So after that little episode, it just goes back to where it was. And if it collapses a little bit, it'll heat up. The heat will push back, and it'll go back to where it was. So I think the sun's going to be roughly the same tomorrow. Um, if you get the strength of gravity too strong, all the stars in the universe, rather than having the stability, turn out to be unstable. They overreact if anything sort of pushes them a bit, and they pulse, and eventually they explode. We see stars like this in our universe, but it's only the most massive, enormous stars that do this, but make gravity stronger, and every star does this. We can also look even bigger to the expansion of the universe. Now, hopefully this video comes through looking sort of okay. This is how we think galaxies fall from the Eagle collaboration. In an expanding universe, which actually isn't showing you the expansion's factored out, but lumps of matter grow under gravity to become bigger and bigger. So anywhere that's sort of dense in the universe has more of a gravitational pull on everything around it, so pulls more and more stuff in. Then you get this sort of structure where you have voids, empty bits of the universe where there's not much there because those bits have been pulled to somewhere else, what are called knots, where there are galaxies and clusters of galaxies. And then the bits in between, which haven't quite decided which way they want to fall yet, which are the filaments. What my colleagues and I have done is taken the same simulation and asked, well, what if we changed some of the numbers of the universe? A particularly important one is known as the cosmological constant. Now, we don't need too many details here, other than it's putting a number on. It's responsible for the fact that not that our universe expands, but that the expansion accelerates. The universe is expanding faster today than yesterday. And as with the masses, there's a range of values it could have. And so what we did was to simulate. When I hit play on this, it'll simulate 3 of them. I haven't done anything yet. Nothing's happening. Basically, our universe on the left, what if there was 10 times more cosmological constant? What if there are 100 times more cosmological constant? So as you can see, time's going up. All the simulations start roughly the same. But because the influence of this number, parameter, cosmological constant, hits later in the universe, you see basically everything in this universe over here is accelerating away from everything else in the universe. So it expands extremely quickly, and there's very, very little structure that actually forms. So in our universe, you have the cosmic web, lots of structure on all sorts of scales, making all sorts of interesting things, galaxies and clusters of galaxies and stars and planets and all the wonderful stuff that we live on. 10 times larger, and you get isolated galaxies. You just get left behind. The cosmic web sort of pulls apart, and 100 times more. There's just not much stuff out there. Now, that's comparing these universes to our universe. Compared to the total possibilities of what could have happened in our universe, this is actually an extremely small change, sort of 1 part in 10 to the 120. Now, you could start changing other values, just as we did a three-dimensional plot with what if I change more than one value at once. At best, you've got about 10 to the power of 90, which means there's a one chance if you took the total range of this number and picked it from it at random, and then after that, you're allowed to change whatever other number you want to try desperately to make life happen in the universe before it all expands too quickly away. You've got one chance in a number with 90, 91 digits in it to get that right. This is the fine tuning. So to put a picture in your head, what goes wrong in all these other universes is simply that every particle is just surrounded by empty space. That's all that ever happens. Like maybe once in a trillion years, some other particle comes along and just bounces off it, and that's it. That's the whole history of the universe. So this is called the fine tuning of the universe for life. I've just noticed this is an old version of this. AM and FM are the wrong way around. Sorry about that. But the idea here is if there's the outcome, the music you want to listen to on the radio dial here, in a non-fine-tuned case, you could just set the dial anywhere and some interesting music would be there. But if you're very fussy, then you've got to get it exactly on your radio station because, almost exactly maybe, just a little bit to the left or a little bit to the right. And you're listening to static or you're listening to something else. So all of these sorts of examples are there in the scientific literature. My colleague and I, Geraint Lewis, we summarized them in this book of ours called A Fortunate Universe, Cambridge University Press. Geraint's an atheist. He's not, I'm a Christian. He's not, he's an atheist. But we agree on all the science, on what would happen if these numbers had been different. What we disagree about is the interpretation. So getting back to Dawkins, however, this rematch, what, are the physical processes that shaped our world boring and simple and unremarkable and typical? If we look at them, will we be tempted to invoke design? And the answer is yes. So these processes, they aren't. They're not boring. They're not typical. There's something really remarkable about the electrons you're made out of. Now, got a couple of minutes left before the half hour. Let me just quickly go through a very common objection. The multiverse, which says, what if, okay, look, you've got to get these numbers right if you want a universe with life in it, but what if out there's lots of other universes, and so our universe just won the cosmic lottery? So just as if you buy enough lottery tickets, enough different lottery tickets, you'll more likely to win the lottery. What if basically the universe made life just by buying all the tickets, lots of tickets, random tickets? So somewhere out there had to be life. The problem with this is if we're serious about attacking this question of, the design that I see, does it follow us down through the layers of biology, chemistry, and physics? You've just added another layer. So there's biology. What happens if you throw cells together at random? It doesn't fly. So there's something to be explained about the fact that we see things that fly. What happens if you throw a universe together at random? It doesn't do anything interesting. It doesn't make any complex structure at all. So there's something to be explained about the fact that our universe makes complex structure. Okay, let's go another level of physics. What happens if you throw a multiverse together at random? And the answer to that question is we don't know. We just don't have a standard theory of the multiverse where I could get a hold of it and start to think about what would happen if it just sort of threw it together at random. It's very easy to imagine a case where it might solve fine-tuning, but you're just making stuff up at this point. Because the fact that some level of structure in our universe, the biological level, gets explained by a level underneath it, that's not enough to get rid of this design intuition. It followed us from biology to chemistry, from chemistry to physics. It might follow us all the way down to the multiverse. We just don't know because we don't have the physics there. So what I'm saying is this is an argument that's just grounded in the best information we have, the level at which we can actually attack this question. So that's my summary of the fine-tuning argument. It's laid out in the one on the right. Geraint and I have written another book that's on the left. That's just about the evidence for the Big Bang. Yeah, there is my summary of the fine-tuning argument.
Dr. Barnes, thank you for your insightful presentation. And I just wonder what would happen if electron suddenly changes in his tuning, in his mass. What would happen next? Would we disintegrate or explode or what?
Well, so it depends what change you make. In some cases, what happens is that in our universe, a neutron, if you leave it alone, will sort of fall apart, undergo a weak interaction to be a proton and an electron and something called a neutrino. If you make electrons really heavy, you sort of reverse the way that that wants to go. And so basically a really heavy electron is the sort of thing that would rather combine with a proton and make a neutron. So you're in danger of making a neutron-only universe. So rather than our universe, we've got the periodic table, it's all happening. You can make atoms and electrons, great stuff, chemicals and all that. You just have neutrons, and that's it. That's the whole structure of the universe. It's important, actually, sort of a technical point. There's a difference between asking what would have happened if the universe had a certain set of constants from the start versus what if I could change the constants right now with a click of my fingers. That second one's entertaining, but we actually need to ask the first question to make sure that we're not just, that's not what we're supposed to be imagining. It is entertaining, though.
Okay, fair enough. Next, if universe is designed, why would we need a 13.7 billion of years of cosmic evolution? Why God didn't do that more quickly?
So what's important about this argument is that it's fundamentally when you lay it out. So I've laid it out in an article that I called A Reasonable Little Question. You can go and look it up online, where I tried to just give the best form of this I can do. It's published in a philosophical journal called Ergo. It's a probabilistic argument, which means it's not saying what has to happen, what must happen. It's not a deductive argument where it's just a proof of anything. It's about weighing up probabilities. And so at a certain level, the questions it leaves unanswered simply sort of add a bit more improbability to one side or another, but don't fundamentally change it. So suppose I walked in here on my birthday and I find that is written on my little whiteboard here, it says happy birthday, Dad, right? I've got two kids out there. And I think that my kids wrote that on the board. And then you think, okay, well, if they wrote it on the board, why do they use the red whiteboard marker rather than some other whiteboard marker? And the answer is that's a fine question. You can ask that if you like. And if we don't know, then we don't know, but it doesn't make it impossible. If you're trying to weigh up two different possibilities here, two different sort of theories, one is, my kids wrote happy birthday on the whiteboard marker or on the whiteboard, or, my dog grabbed one of the pens and was just sort of chewing it and accidentally put that message on the board. You just look at what do these sort of uncertainties do to the argument. And obviously, in the case I made up about the happy birthday thing, the red pen just doesn't change things very much. If there's, 5 colors of pen here, then there's right random, a 1 in 5 chance it'll be red. And so it's just not that bad. Even if all the probabilities go down by a half, it's still way more likely than my dog accidentally writing happy birthday on the board. So in this sort of case, why would God do this? Well, I can just say, I don't know. And I wouldn't expect to know from fine tuning. And that doesn't in any way significantly change the argument. I mean, another question would be why 13.7 billion years, given some other hypothesis about the universe, given, naturalism, for example, the idea that the universe is just there. Why would we be 13.7 billion years afterwards? There's not much of a reason there either. So in the end, those sorts of facts that don't get perhaps predicted by either side just come out in the wash. Right? If I'm weighing up two cases and some fact comes along that doesn't particularly fit well on either one, then it just, put it there or don't. It just doesn't much matter. Beyond that, if that's the way God, there's a certain sort of logic to the way our universe is in fact put together, given the way that stars shine, given the sort of constraints on the constants you need for atoms to form, how you might have stars form in the same context, all that sort of stuff. There's a logic why it would take that long. God doesn't have to do it that way, but it's not a ridiculously unlikely thing. Just as my kids using the red pen over the blue pen just doesn't, I mean, sure, it just doesn't matter that much.
Yeah, great answer. Okay. Is the fine-tuning of the universe a brute fact, or does it require an explanation? Recently was a survey, scientists said about 21.7% that there is no fine-tuning. So what is your opinion?
I haven't seen that. I'd be very interested to see that particular survey. One of the problems we've got is that the term fine tuning has a sort of technical meaning in physics, but it it's a feature of the analogy that you fine tune something with a hand, right? Think about the hand on the dial. And so to a lot of people, it sounds like when you say the universe is fine tuned, they think it means the universe is designed. And that's not what it means. It's what it might imply that you might be able to make it might be evidence for that, but it's not what it means. So I'd be worried about any sort of survey that asks that question without explaining its terms first. So, sorry, I've forgotten what the first. Oh, could it just
Yeah.
be a brute
Is it
fact?
Yeah.
Um, Look, that's an option. Again, we're weighing up possibilities here. If I walked in and on the board here, there was just some random collection of lines, I might think that, the dog who doesn't understand anything would, just happen to grab a pen and with its mouth and put it on the board. So, in that case, I wouldn't try and read it. I wouldn't try and infer anything from it. Um, that's an option. And does it explain the data? Well, the problem is these fine-tuning cases, you end up with some really, really, really small probabilities really fast because the ranges of these values, even considered across multiple dimensions, multiple parameters at once, um, they're really small. If there's a wide opening here, when you've got something that's improbable, it doesn't necessarily mean it needs an explanation, but it means there's an opening there. There's a chance for something to come in with a better explanation.
All right, great. Next, can the likelihood of a life-permitting universe on naturalism be calculated using probability distributions?
Hmm. Yeah, so this is one of the things that I attempted in the paper that I mentioned before, a reasonable little question. I think it can, but it's important to remember what sort of probabilities we're talking about here. So probabilities that you learn in high school are things like, I flip a coin, I roll a dice, those sorts of things, where it's a way of thinking about the sort of experiments that get done lots and lots of times. And I roll a dice and I roll another dice. How often does a six come up? There's a broader, more general sense of probabilities that we use in science called Bayesian probabilities. For example, I might want to say something like, um, given all the evidence we have from astronomy, is Einstein's idea about gravity more likely to be true than Newton's idea of gravity? That's a question I might want to ask, and I might want to try. It'd be great if we could try to put some sort of, degree on that. So it's not just a little bit better; it's a lot better, or whatever. That can't be a rolling the dice kind of probability. I'm not saying that, if the universe, so suppose it's 10 times better. I'm not saying that the universe spends 10 days obeying Einstein and one day obeying Newton. Or if I looked at 1,000 solar systems, I'd find 900 obeying Einstein and one obeying Newton or something, and the rest obeying Newton, sorry. What it's about is trying to put a number on the way one idea supports another idea, one proposition, one statement supports another statement. So if, there are clouds outside supports it's going to be raining within an hour. It doesn't prove it, might be wrong, but it does change the way we weigh things up. If there's no clouds in the sky, supports it won't be raining in an hour. Again, might be wrong, but you take whatever you thought the probability of rain in the next hour is going to be, and if you see blue skies, you sort of lift it up a little bit. Once we've got that in mind, I think the apparatus is there. The sort of bits that we need from probability theory and from physics are there to try and get a handle on. And again, it's an approximation thing, but try to get a handle on the sort of degree to which our universe seems unlikely, given the laws of nature and given no further hypotheses about our universe other than that.
Awesome. Okay. Next question. Is the assumption that naturalism is non-informative with respect to the fundamental constants justified?
Yes, I think it is. So here's the idea there. The idea is as follows. To naturalism, the universe really is a brute fact, so to speak. The existence and fundamental properties of the universe are just a brute fact. I take that to be sort of definitional of naturalism. In other words, there's no deeper reason for why the universe exists and no deeper reason for why the universe is the way that it is rather than some other way. Just is, that's it, you're done. Down at that fundamental level. So I think the way to model that, the way to try to understand that, try to get a handle on that is what we call non-informative probability. So if I've got a dice here and there's 6 sides and it's fairly weighted, and I say probability of rolling a 1 is 1/6, we call that a non-informative assignment because it doesn't give me any reason to prefer a 1 relative to a 2 relative to, if I say they're all equal, then that's the sort of non-informative. On the other hand, if I said, look, here's a die, it looks evenly weighted, but actually the probability of rolling a 6 is 90%, and all the other sides are sort of 2% each. Now I've given you some information there. I've really given you information. Like if you were at some table in a casino, and I give you that little tip about the way the die is going to roll. I've told you how to place your bets. I've given you great information there. So amongst all the ways you could assign probabilities to the dice to each side, there's one which gives you no information, and that's just obviously in this simple case, probably 1/6 for each of them. There's equivalent things when we're dealing with probabilities over finite spaces, a uniform distribution. It's the sort of default, given the sort of situation we're trying to model, that's what you would use. Any other probability distribution would be telling you something, but the whole point of naturalism is there's nothing to tell you anything about the way our universe is supposed to be. So again, it's a modeling thing. We're trying to just sort of take the situation we're in and seeing if we can get a handle on it with some numbers that might represent the situation we're in.
This seems so easy for you. So here is a tough one question. If God created everything, then everything is designed. We would agree. So what are you using to compare designed things versus non-designed things? For example, what are you using to compare to recognize that DNA is designed rather than not? Is there anything that is not designed?
So remember what Dawkins compares it with, the thing that flies versus the thing that's dead. We know what inorganic matter looks like, right? Rocks, right? If we, me and the ghost of Richard Dawkins as unembodied spirits, now that's a normal situation for him, but never mind. We get transported to a universe, and all there is just rocks, and that's it. Imagine like an asteroid field from Star Wars or something. There's just chunks of rocks flying around an otherwise empty universe, and that's it. That's everything that exists in that universe. And you would and it would be pretty obvious in that case that that doesn't look particularly designed on that sort of level. It doesn't hit us with the same sort of impact that seeing a hummingbird does. And you think, wow, I mean, that thing flies and it's, this big. That's incredible. So if God exists, then everything is designed. But um, if naturalism exists, then nothing is designed in at a mental level. And so the question is, not it's true that if God exists, everything is designed in that sort of sense, but not every possible thing. The whole point of design is that there are some things that God wouldn't make or is very unlikely to make. It seems like God wouldn't make a rock only universe. Um, it just doesn't, it doesn't have anyone there to appreciate it, or whatever reason God has for making a universe. It seems like there wouldn't be one there, or at least it's less likely. I don't have to say that definitively. We're weighing probabilities. So what Dawkins compares a hummingbird to is what he's comparing it to is what a random collection of cells would do, which is not fly, right? You may throw cells together at random over and over again for 1 billion years, and you'll never make something that flies. So he's comparing a hummingbird to a random collection of the same cells. And that's where you find the evidence for design. And so what are we comparing it to? Well, we're comparing it to the ways that we can not just imagine, but calculate from physics the way the universe could have been if it was thrown together at random.
Oh, awesome. Okay, my friend is an atheist and also philosopher, and he said this theory. So just listen and answer on this. He says, so there's the conjunction of naturalism and the idea that we live in long-run universes. Naturalism posits that there's at least one long-run universe that has existed for 13.7 billion years. Containing elements like hydrogen, carbon, oxygen, up to iron and planets. The motivation behind this theory could simply be to explain these observed facts. Just as you offered me a specific version of theism, I'm offering you a specific version of naturalism. I'm not clear which one would predict life-permitting conditions more than the other, and I see no reason to believe that one is more ad hoc than the other. What's your answer on this?
So how specific do you have to be in order to get your version of naturalism, your specific version of naturalism? How specific do you need to be to actually get a universe that creates, let's say, any complex structure in it? And again, you can't do it, to be naturalistic. There can't be something like, well, there can't be foresight, right? The conditions at the start of the universe can't depend on something that happens later on, unless you've got some very weird naturalistic universe. But let's leave that aside. And so it's not really a question of can you come up with a naturalistic universe which has life in it? Yes, you can, if you give enough specify enough details. But then this is the point. Let me give an example, one I've used an awful lot of times. Suppose you're a detective, you're a police officer, and you are called to a crime scene. There's been a robbery at a bank. You walk into the bank, the vault is open, the money is gone, and so you say, okay, let's look at the security camera footage. Okay, you go into the security guard's office, he puts in the footage, and you see the robber walks into the bank, walks up to the vault, and there's a combination code, some numbers you have to put in, and you've got to get, say, 12 numbers. And the robber puts in exactly the right 12 numbers, puts in the correct code, hits open, opens the vault, takes all the money. There's your data. Now, here's two hypotheses. One of them is that the robber guessed the code. In other words, say he just walked up and put his favorite 12-digit number into the thing. Didn't know whether that was the code or not, but just he, for some reason, has a favorite 12-digit number and just went, well, I might as well try that, and then just put that in. And oh, it opened up. Fantastic. Took the money. The other theory is that the robber was helped by someone at the bank who knew the code. They told him the code, and then he went and put it in. That's why he got it right the first time. So the guessed hypothesis, I just guessed the number, right? My favorite number. And the inside job hypothesis, someone inside the bank told him. Now, can you come up with a version of the favorite number hypothesis which explains the facts? Yes, you can, as long as you're specific enough. You have to be very specific. You have to specify in your hypothesis that the favorite number of the bank robber is the same as the number that opens the vault. In other words, you've got to match those 12-digit numbers. If here's the, if the, whatever the bank vault number is to get in, your hypothesis needs to specify all the same digits to be the favorite number of the bank robber. And that's the problem. The other hypothesis doesn't have that. Because it's guaranteed on that hypothesis that the bank robber will walk in there with the correct number, whereas the other one, it's not. It's not about whether you can specify a version that works. It's how specific do you have to be. The problem with naturalism is that fine-tuning raises is precisely not that this universe is impossible, but it's not typical. It's not just any old universe. I mean, you can specify, if you wanted to play that game, you could just specify our universe 5 minutes ago and say, that's the naturalistic universe that exists and all our memories are wrong. Like, just specify that universe. No one would accept that because you have to specify hummingbirds, and no one's going to say, hey, hummingbirds just exist. But if we have exactly the same problem at the start of the universe, you've got to get all these numbers right, then you're in exactly the same situation. You're having to provide a lot of specification in your hypothesis, whereas other theories don't. If you just say there's a God who wanted to make a universe that has embodied conscious agents in it, as Robin Collins puts it, then suddenly that does an awful lot of work. Suddenly that's faced with the whole space of up quark, down quark, that thing I showed. Suddenly, yes, we're going to be somewhere in the little slice that actually does something interesting. It does work for you.
Amazing answer, thank you. But he continues and he says, I don't see a reason to think that Omni-atributi lead to life in the universe.
Okay, so again, this is a probabilistic argument. So there's a factor there for what's the probability of a life-permitting universe on naturalism, and fine-tuning answers that, and it's very small if that bit convinces you, right? It's all laid out in the paper. The other bit is what's the probability of a fine-tuning universe on theism? And I don't need to argue that it's 1. I don't need to argue that it's 50%. I don't need to argue that it's 1 chance in 10. It could be 1 in a billion, and this argument still works. So I don't see a reason why an omni-god would create a universe at all. Okay, unless you've got a really strong bias against it, the argument will be fine, right? I don't see a really strong argument why my kids would use the red pen. I don't need a strong argument why the kids would use the red pen, because the alternative is that the dog did it, right? If there were a million pens and they picked one very specific color of purple, right? And there's a 1 in a million chance that they would have picked that color of purple, still more likely than the dog writing happy birthday, Dad on the board. So these are the sorts of issues that just come out in the wash. This is why the argument's so powerful. I don't need to assume that much about God at all, unless you've got a really, really strong reason why you think it's impossible, the sort of omni-God, omnipresence, omniscience, all that sort of stuff, definitely wouldn't create a universe, then the argument will still do just fine.
Okay, but many assumptions are built into theism to arrive at the conclusion that God better predicts a life-permitting universe. The existence of God brings with it a bundle of many paradoxes and potential contradictions regarding omni-attributes. So, therefore, when taken into account, even if there is a strong case for theism, it is the least likely because it entails many other things that make theism improbable.
Well, I mean, then you've just got to weigh it up. So the way I lay it out in the paper is not the conclusion is not therefore God exists or therefore theism is true. The conclusion is therefore a life-permitting universe is very strong evidence for theism over naturalism. In other words, wherever your probabilities were before, theism gets a boost. Now, that's a relative thing. It's not an absolute thing. So you could decide, actually, yes, that's all fine. The fine-tuning argument would boost case for omni-God. But actually, I've got other reasons to think that the probability is so low that even the boost that it gets from fine-tuning won't make a difference. And you can say that, and that's all perfectly consistent with the fine-tuning argument. For example, if you think there's a logical incompatibility in the attributes of God, then the probability would presumably be zero that God exists, in which case, yeah, there's no boosting zero, right? You can't multiply zero by something and make it bigger. All fine. What fine-tuning does is to say, okay, just weighing the numbers here, the hit that naturalism takes relative to theism when we take fine-tuning into account is really, really big. Right? The numbers that just come out, go look at the calculations. There's hundreds of zeros, at least 100 zeros, very big numbers flying around. So you better be pretty certain that your arguments about the incoherence of theism are really, really good to ignore the fine-tuning argument. Now, there's sort of gestures in the question. Obviously, we can't go into those details, and you should be taking those up with a theologian, not an astrophysicist or a philosopher. But I don't. I mean, I can give a half sort of baked my answer to some of these issues. I don't see any. I see some things that are confusing and perhaps very unlikely given theism, like the problem of evil, but I don't see logical incoherences.
Yeah, this is clear. Okay. Next question. What is the role of the principle of sufficient reason in the fine-tuning argument?
None at all. It's not. It doesn't assume the principle of sufficient reason. That's the cosmological argument. So, um, beyond the fact, I think it's almost impossible to think without actually assuming that particular principle. It's one I support. It's just not explicitly assumed in this particular argument. As it's laid out, all I need is what's called the likelihood principle, or some sort of relationship to that, which is basically the theory that leads us to expect the data we actually see is the one that's favored by that data. It's a very sort of straightforward probabilistic thing.
Nice. Okay. Next, how do we know that fundamental constants of nature are not themselves necessary truths?
Two things. One, look, the future of physics might change the way we think about this argument, and that I'm actually kind of fine with that. Like, it's based on physics, so I'm using the best physics we've got, which is supported by data. So if it all changes tomorrow, you know, that's not necessarily going to raise fine tuning. Sometimes the advances of physics have made better fine tuning cases. So there's no definites there one way or another, but we'll look at it again tomorrow if better physics comes along tomorrow. That's fine. We're just taking stock of where we are. Great, right? Remember, Dawkins said, physics is the sort of thing that doesn't tempt us to design. It does. If you want to say tomorrow's physics might not be the sort of thing that tempts us to design, then great, we'll deal with that tomorrow. But on this thing of what if the values of the constants are necessary, the important thing about that is that's not a scientific conclusion. It can't, like, science just does not deal in those sorts of modal, as they're called, categories. Science doesn't say what's necessarily true and what's contingently true. It just, you know, looks at data and tries to explain it. I guess everything's contingently true on science. There's nothing there that there's no observation you can make of the world that tells us that that's something is necessarily true. Mathematicians can do that, but physicists just can't. I see a star over there. There's no data that can come through my telescope which gets labeled necessary truth. It's just the wrong category for what we do as scientists. So if you want to make that sort of case, you're doing some pretty heavy metaphysics, just to be perfectly honest. I mean, you're really doing the sort of thing with a scientific theory that no physicist does with a scientific theory, of taking a bit of it and raising it up to the level of, metaphysical necessity or something. If you want to do that, feel free, but I mean, just realize what you're doing. And you're going to have to provide some pretty heavy, hardcore argumentation for why you think we should support that. Although I should say, this is the sort of idea, I think, as far as I understand him, that Graham Oppy is trying to do. He's a analytic philosopher of science, of religion, not a Christian, not a theist, an atheist. Actually, in Melbourne, in Melbourne, in Australia. So I don't really understand why he does that or what the rules are of that, but that is an approach some people have taken. I'm just saying, as an astrophysicist, it's just nowhere in my skill set or vocabulary.
Thank you. Is the fine-tuning argument vulnerable to the objection that it conflates improbability with impossibility?
No, not the way I lay it out. Some people are a bit vague. Look, I mean, in popular level presentations of it, not everyone's as precise as they probably should be. But no, everything in the argument as I lay it out, especially in the paper, it's all about improbabilities. Again, impossibility is like necessity. It's just not a category I can get out of physics. I can't say something's impossible in physics. I can say mathematically, I think some things are impossible. 2 and 2 is 5 or something, but not physics. I can say something doesn't happen in our universe. I can say it wouldn't happen in any universe that obeyed these laws of nature, but impossible in no possible universe. That's just not anything I can make a conclusion about.
All right. Does the fine-tuning argument assume that the universe was created with life in mind?
No, it doesn't assume that. It tries to prove. It tries to give evidence for it. So it's not an assumption. It's a conclusion. Uh, you know, created with life in mind, I assume, is roughly equivalent to theism is true. God exists, a creator God exists. And no, that's not an assumption behind the scenes that we just assume this is true, right? If that were true, then I wouldn't need the argument at all. If we could just all assume that, then it would all go home. Um, no, that's what the argument's trying to prove, not what it assumes. Well, not prove, give evidence for.
Yes, okay. Next, is the fine-tuning argument a version of the argument from design? And if so, does it suffer from the same weaknesses?
Um, So the argument from design is a very broad category of arguments. So you have ones like William Paley's argument from design. You have things like Thomas Aquinas's fifth way. There's a bunch of things which have got the label argument from design. Actually, as people have tried to explain it to me, probably the fifth way of Aquinas isn't one of those, but that's another story. The argument from design, the most famous version is from William Paley, and that is manifestly, obviously, right on the surface, an argument from analogy, right? Look at, imagine you found a watch in a field. What would you think about the watch? Why would you conclude that it couldn't have just laid there, that there must be a designer of the watch? Here's all the things you say about the watch. Here's all the things you say about life as we see it around us. And look how perfectly they all match up. That's an argument from analogy. Um, Phenomenal argument from analogy. It's a very detailed argument from analogy, but that's the form. Mine's not an argument for analogy. The fine-tuning argument is not an argument from analogy. It's a probabilistic argument. It's an inference to best explanation, if you want to put it that way. So it's a sort of Bayesian design inference. So on that level, no, but it depends what sort of under the category of things that the design argument has been criticized for. That's a big field. So if you want to be more specific, then maybe they do apply. But on that basic level, I'm thinking of Hume here, saying it's an argument for analogy, but and those aren't always good, and we don't really have a good handle on what are the good ones and what are the bad ones. That doesn't apply to at least the right sort of form of the fine-tuning argument.
Yeah, but the objection is, let's say we find something that is clearly not designed, and we say, okay, this is not designed, so also universe is not designed. Does that refutes that argument from a watcher or something?
So Paley's quite clear about this. Paley considers William Paley, 1800s, natural theology. You're in a field and you find a rock, and you'd be happy to say the rock is just there. It's just laid there. You wouldn't think any more about it. You find a watch, right, and you think differently. The point is not that the rock isn't designed, as in it's not the intentional creation of God. It's just that it's not obvious evidence for design over a purely, say, naturalistic origin. And so it's not that some things are designed, for Paley, some things are designed, they point to design, some things are not designed, they point away from design. It's just some things are neutral, right? So the watch points to design, the rock, one way or another. Maybe someone did put it there, maybe it didn't. It just doesn't help us. And so there's not a weighing up of things designed and things not designed. There are just some clear cases where it goes one way rather than the other. That's Paley's version. Again, none of this actually is assumed by or relevant to the basic fine-tuning argument. It's quite different in that sort of sense.
Yes, I agree. Okay. Is the fine-tuning argument an instance of the fallacy of inferring a design from complexity? In other words, why don't we say we just don't know why is the universe fine-tuned? We will find out one day, as Dawkins said. What is your answer?
No, I don't think inferring design from complexity is a fallacy. It's how we infer design all the time. Not all complexity, but complexity pointed towards a particular function, maybe. So I reject the idea that that's a fallacy. But it's not the fine-tuning argument. Complexity doesn't come into it. It's just a question of here's some data. How likely is it given one hypothesis? How likely is it given another hypothesis? It's not like the arguments from the intelligent design movement. Michael Behe and Steve Meyer and those sorts of people. It's just a different argument. It's not arguing from complexity specifically. It's not arguing on the basis of analogy. It's not that sort of thing. What if it's not just saying we don't know, because the whole idea of the argument is, look, on naturalism, fundamentally, it's going to get to the ultimate laws of nature and say, that's it, we're done. That's all the explanation for anything you're ever going to get. And it's not the case that naturalists say, look, at the moment, because we don't have those ultimate fundamental laws, we can't know whether naturalism is true or a better hypothesis or anything like that. Dawkins and Sean Carroll and a whole bunch of naturalists are quite happy to say, look, the evidence we have points very strongly towards naturalism. And they're not waiting around for the last final, the future of physics to say that sort of thing. So when Dawkins says physics is the study of things that don't tempt us, of simple things that don't tempt us to invoke design, he's not saying in the future, he's saying now. So, I mean, let's look at that claim now, at physics now, and see whether he's right and he's wrong. So I'm fine with it being the sort of argument that we might look at differently tomorrow. But it's not true that the progress of science will erase fine-tuning. There are plenty of cases in the past where the progress of science has cemented fine-tuning or made it worse. No one really took the fine-tuning of the cosmological constant particularly seriously until we discovered that, science made progress and discovered that our universe actually has a cosmological constant. So there's the progress of science. There's us explaining data better than before. There's us learning something about our universe, and there's more fine-tuning than there was before. So it's not the case that the progress of science will just automatically erase these sorts of arguments. They could get worse, and the best handle we have on them is the physics we have now, which is fine-tuned.
Great. What would you say to agnostic position? They would say, for example, I'm not convinced on either side, so they are equally possible. So,
I mean, it's not an argument about possibility, it's about probabilities.
yeah, probability. Okay.
So start off agnostic, sure. And then look at fine tuning and the argument I presented, if you think it's a good argument, kicks the probability of theism up by an awfully large factor and knocks the probability of naturalism down by an awfully large factor. And so, yes, look, there's no proof here. There's nothing that is 100% this or that. It's all about weighing up the evidence. This idea that naturalism, that science has just explained everything about the universe and it's all fine and it's exactly what you would expect if there was that bottom. This is a quote from Dawkins, actually. The universe is exactly what you would expect if there is a bottom. No design, no purpose, no designer, just blind, pitiless indifference. That's almost a perfect quote from Dawkins. Well, is he right? I mean, he's not saying science when we finally understand all the ultimate laws of nature we don't know about looks like that. He's saying the world we see is like that. Well, we can test that. We can look at physics, not just biology, and actually try to get a handle on how would I actually calculate? How would I actually get some sort of handle on, is this universe what you would expect if naturalism were true? We had the laws we have, but you throw a universe together at random by picking out the values of the constants. And the answer is no. That's the whole point of fine tuning. And if you should take that seriously, if you're the sort of person who thinks that, Dawkins, those sorts of arguments, if they turned out the other way, they would be worth taking seriously. If it turned out any old constants would be fine, then, Dawkins would be saying physics vindicates me. So you should be worried that it doesn't.
Okay. Sorry for many questions. We are heading to
These are
end,
good.
so a few more. Okay, thanks. Does the fine-tuning argument presuppose that the universe is the product of a single designer?
It doesn't propose that. The way I've laid it out is I've artificially, as it were, just narrowed the field between naturalism and theism. If you buy that, right, the main point that I think naturalism does, that this argument does, is it takes naturalism, the idea that the universe is all there is, nature is all there is, it takes that and knocks it down by an awfully large factor. What survives, and we can have a debate about what's left, okay? So if I understand the way ink gets on a board, right, I can pretty easily knock down the hypothesis that the dog wrote happy birthday on the board. But which of my kids wrote it? That then we can have maybe they wrote it together, maybe one of them, maybe the other one, then we can have a discussion about that once we've gotten the dog out of the way as a hypothesis, so to speak. So, is there a single designer? Look, these are all, I think, interesting open questions. And at worst, we might come back to the point of, okay, the fine-tuning argument just doesn't decide that for us. We're going to have to decide that on other grounds. We're going to have to try and weigh that up. Now, I think there are other good arguments for the existence of God. I think the cosmological argument, especially the sort of Leibnizian contingency argument, I think that's a good argument. I do think the principle of sufficient reason, or something like it, is true. Alex Proust would be the person to go to for that one. I think there are good arguments, and in particularly, and I'm a Christian, so I think specific as did Jesus Christ rise from the dead, and the argument even if it a single designer of the universe, it wouldn't tell you whether it's God or whether it's Allah, whether it's the Bible or Allah. And that's all right. I mean, of course it won't. We're doing physics here. You're going to have to look at the life of Muhammad and the life of Jesus and all of that stuff. And we can do that. That's wonderful. I'm an astrophysicist. I don't have any, I have an interest there, but not much expertise. But that's fine. So, if you really are taking seriously the idea that the universe has a designer, then we can have an interesting conversation about a single designer, a finite designer, and a sort of omni-god designer, one who's interested, deism, pantheism, all these sorts of things. As long as we're having a conversation where naturalism has been recognized as being a complete failure and thrown out, that's fine. Let's have that conversation.
Nice, but this is personal question. Do you see, when you observe a universe, do you see anywhere something that points to specifically Christian God or Jesus Christ and his character? Do you see something in fine-tuning argument or universe and anywhere?
Not so much the fine-tuning argument, although so there's a point where you ask as part of the fine-tuning argument, why would God what's the probability that God would create a life-permitting universe? If you start fleshing that out in terms of more specific details about God, um, if it's the Christian idea of God, I think that follows fairly straightforwardly. So this has been laid out in detail by, amongst other people, Richard Swinburne in his book, The Existence of God, which I recommend. It's if God is love and love is by its nature sort of self-giving, then the idea that God might want to create other beings capable of love, finite but embodied conscious agents, and they would want to be the sort of people who have serious, who have moral lives, not just trivial. They can really make moral decisions and really properly, influence each other. I would expect that on Christianity, and so that provides a good basis then for that premise of the argument. Beyond that, I think that the fact the universe obeys laws at all, I think is also an interesting thing. Not specifically Christian, um, as opposed to say Islam, but the ideas of God there are much more similar. But if you had two gods, or the gods of ancient Greece or something, who just sort of fight each other on Mount Olympus, them coming up with vector calculus to explain to lay down the principles of electromagnetism, that's a bit more of a stretch for me. Again, these are just weighing up probabilities and plausibilities. That I've got no proof of anything there, but that's the sort of things that for me as a Christian resonate, that fit together well for how I think about the world.
Awesome. All right. Is the fine-tuning argument vulnerable to the objection that it fails to take into account the possibility of future scientific discoveries?
Um, as I said before, it's it's not the case that future scientific discoveries will necessarily make the amount, sort of degree of fine-tune of our universe less, and so it'll weaken the argument. There have been times in the history of physics in the last couple of decades where the progress of science has made the fine-tuning argument stronger. So I think that for example, the 26 years ago, when we found out there really was a cosmological constant in our universe, the fine-tuning case got way stronger because now the cosmological constant's on board, and it's a very, very strong case of fine-tuning. So in that case, what would it take for future science to overthrow the fine-tuning argument? The answer is it would need to radically reverse what we think about the sort of space of possible universes given the laws of nature versus the way our universe actually is. It would have to reverse a very strong trend we've seen in physics over the last 100 years, as we've been able to look into these fundamental theories. So it can't be future proof because it's relying on it is specifically an argument about the best science we know today. But it's not the case that the progress of science will automatically make it weaker. It very possibly could make it stronger. And it's only ever claiming to be, Dawkins is happy to say what physics says. I'm just saying what it really says. It's what does the best science we have today tell us about the universe?
Okay, you are just playing with this question, so nice. Okay, how does the fine-tuning argument account for the problem of evil and the suffering in the world?
So the argument itself doesn't, because it's not trying to say what does all the evidence we have, everything we know about this universe say about the existence of God. That's the $60 million question. It's not looking at all the evidence because that's a lot. All it's saying is, okay, here's a piece of it. Our universe is life permitting. What does that piece say about theism versus naturalism? And it turns out, rather remarkably, that seemingly simple little piece, the universe is life permitting, puts a massive dent in naturalism. Now, there's other stuff around, like the problem of evil, but that would go into. So, the conclusion of the fine tuning argument, as it's usually stated, is just look, this bit of evidence changes the probabilities, but it's not that there's no conclusion that therefore God probably exists because there's more things to take into account. So, on that, the problem of evil is obviously very important. It's also a sort of thing that argues that considers is this the sort of universe we would expect if God exists, versus the sort of universe you would expect if naturalism is true or something else is true. And so it's a very, very serious problem, one that you should ask a theologian. Obviously, I've got my 2 cents, but I'm an amateur, on that sort of level. I'm no philosopher or theologian. So obviously super important. It's just the fine-tuning argument doesn't try to take in all the evidence and see what happens. It focuses its attention on just this one little bit. Because even though it's a small bit of evidence, it does make a massive difference.
All right. Is the fine-tuning argument vulnerable to the objection that it is an instance of gambler's fallacy?
Of gamblers. Now, there's the gambler's fallacy and there's the inverse gambler's fallacy, and I always forget which one's which. But it's a very simple argument, so I'm going to say it doesn't. There's no sort of no space for it to go wrong. The argument, the mathematical form is as follows: there's something like a likelihood principle, which is if the probability of the evidence on this hypothesis is way bigger than the probability of the evidence on that hypothesis, then the evidence favors this hypothesis very strongly over that hypothesis. It's that simple. And then the probability of a life-permitting universe on theism is not ridiculously small. It doesn't have to be large, doesn't have to be a half, just not ridiculously small. The probability of a life-permitting universe on naturalism is ridiculously small. One chance in a number with more than 100 digits in it. That's sort of ridiculously small probabilities. So the conclusion is the existence of a life-permitting universe is strong evidence for theism over naturalism. So that's all it's trying to do. So there's not much space there for sort of fallacious reasoning. It's almost too simple for that.
Okay, last question. Does the fine-tuning argument provide a compelling case for the existence of God, a theistic God, or does it merely suggest the need for further investigation? So, in other words, do you use more arguments for compelling case for existence of theistic God, or is it sufficient alone?
Yeah, no, it's not sufficient. For the reasons I sort of tried to explain. It there are other things that could explain it, but naturalism fails, and that's a really, really important conclusion. But it doesn't it doesn't do anything to help you decide, or certainly nothing particularly convincing to help you decide, say, between Christianity and Islam. And so you're just going to have to take in more evidence. And it doesn't deal with the problem of evil. You're going to have to weigh that up as well. But that's what we try and do. We're in science. It's very hard to get a picture of what does all the evidence say about my theory. But if I can at least understand what the pieces of evidence do for my theory versus someone else's theory, I can start to build up a picture. And so it the fine-tuning argument just takes one of those pieces. It's an important one to focus on precisely because for the same reason we focus on certain bits of evidence in science, because the probabilities, the likelihoods of that evidence are way different on certain theories because it pushes us decisively one way rather than the other way. It's like, the difference between the dog riding on the board and the kids riding on the board. If it was just any old shapes on the board, maybe it was either of them. But if it says "Happy Birthday, Dad," then it was almost certainly my kids. It's that sort of evidence where suddenly one hypothesis gets a massive boost, but it's not all the evidence. And within the hypothesis that gets the boost, there's a number of sub-hypotheses. So Christian theism, is Islamic theism, these sorts of things. Yeah.
Okay, can you just mention briefly by name what other arguments you use specifically for?
Oh, sure.
Yeah.
I mean, I mostly focus on the fine-tuning argument. The other arguments I think are pretty good are the cosmological argument, especially the Leibnizian argument. Anything that argues, why is there something rather than nothing? That there must be a reason why the universe exists rather than nothing exists. A Leibnizian. I think the Kalam argument that there is a beginning of the universe is not proved. But there's pretty good clues there that should be taken seriously, given how surprising they are on naturalism. I think that arguments from morality are at least very interesting. I think they don't rule out all sorts of naturalism, but you have to, if you think a statement like, torturing babies is morally wrong, um, you have to have enough in your view of the way the world is that statement can be true, not just something that we tend to believe, but is really true. It has to attach itself to something in reality. There are versions of naturalism which can try to do that, and we can weigh those up, but I at least have a worldview where that statement turns out to be true. And I think then the historical evidence for the resurrection of Jesus, I think that's something that people can look into in great detail. And the sort of thing that really pinpoints us down to a picture of God. If Jesus rose from the dead, then his ideas about God aren't just opinions. They're worth, believing.
Okay, Dr. Barnes, do you have any conclusion and where people can follow you, your work, and something?
So let me shamelessly plug the book again. The Fortunate Universe. Again, my co-author is an atheist. So the science is the sort of science that an atheist and a Christian can agree on, even if we differ in what it all means. Other than that, if you just actually, I don't really run my own YouTube channel these days. I just rely on lovely people like you. So just put my name into Google or YouTube and see what comes up. There's a bunch of me talking there. And if you put my name into Google, you'll find my website on at Western Sydney University and contact details there and all that sort of stuff.
Yes, I wonder just, can you say what your colleague who wrote the book, what he says about your thinking? What's his objection?
So I think he sort of goes for the multiverse as the answer for fine tuning, and he gives his case there, so you can lay that out. You can read about it there. I think his main problem with God is in my view, his picture of God in his head is a bit too close to the guy with a long beard who sits on a cloud in the sky kind of God, which I don't believe in either, versus
Yeah.
a sort of necessary being who's the creator of everything but himself kind of God. So, but long conversation in there. So the first 7 chapters we wrote together about the science, and then the last chapters about what we think about all this in the form of a conversation.
Okay, Dr. Barnes, thank you for being our guest today. Sorry for my bad English, by the way. Your insights and thoughts on the fine-tuning of the universe have been incredibly inspiring. So I would like to invite all our viewers to subscribe on my channel and follow the work of Dr. Barnes. And yeah, thanks everyone. See you next time.
Thank you.